here I'm going to walk you through a modelling paper. So it's paper 6. I picked this topic because it follows on directly from what we've just been doing in class. So it's going to end up, well not end up, very early on it's going to be about linear inequalities, drawing regions, that sort of thing. So it's a good reinforcement, and now we are ready to move on to paper 6's practice anyway. Right, so this is the second half of a paper 6, the modelling section, and it's about shoes. So let's start. Shoe business. You are advised to spend no more than 45 minutes on this part. This task is about the profit made by making and selling shoes. A company makes and sells two styles of shoe, X and Y. The objective of the task is for the company to maximize the amount of profit that it makes each day. The number of shoes made each day is modeled using inequalities. Each day, the company makes X pairs of shoes of style X and Y pairs of shoes of style Y. It makes at most 50 pairs of shoes. So we've been given the first lot of information, and then we see the first question. Write down in terms of X and Y an inequality to show how many pairs of shoes can be made each day. So I would advise you to not read on past there. So once you get to a question, the information that's going to follow, it's irrelevant. It's as if it doesn't exist yet. You just need to use information that you've got so far. So here we go. Write down in terms of X and Y an inequality to show how many pairs of shoes can be made each day. So we have been told each day the company makes X pairs of style X, Y pairs of style Y, and makes at most 150 pairs of shoes. So the combined total of this X and Y can be at most 150 pairs. So it's an inequality. At most 150 pairs means 150 or less. So the total amount of shoes is 150 or less, and the total in terms of X and Y is going to be X plus Y. So X plus Y is less than or equal to 150. Now that's enough for the marks. You could also think about the lower end of this, as in you can't make, say, -1 pairs of shoe. The least amount of shoes you can make is 0, so there is potentially a 0 here. You could say X and Y is greater than or equal to X plus Y is greater than or equal to 0, and it's less than or equal to 150. First mark on the board. So next piece of information. 2 machines are used to make each pair of shoes. Machine A is used for at least 3 hours each day. Machine B is used for at least 4 hours each day. The table shows some information about making each style of shoe. So we've got different rows in the table. Maximum number of shoes you can make. Time taken on machine A to make the shoes, time taken on machine B to make the shoes, the cost of making one pair, and the selling price. And we've got all of those numbers for both style X and style Y. So what are we being asked first? Explain why X is greater than or equal to 0 and less than or equal to 80, and Y is greater than or equal to 0 and less than or equal to 100. So if you look at the first row in the table, you can see an 80 and a 100. The 80 corresponds to X and the 100 corresponds to Y, and this is the maximum number of pairs of shoes made each day. So this is because the maximum number of pairs of X is 80, the maximum number of pairs of Y is 100, and the zeros are because it's the minimum number you can make. You can't make a negative amount of shoes. So we are going to write max number of X is 80. It doesn't give you a lot of room for this. It is a bit unfair. Max number of Y is 100. So that's where the 80 and 100 come from. We've just got the zeros. So minimum number of shoes is 0, or you can't make a negative amount of shoes. negative amount. So as long as your reasoning is sound and you've basically covered all three of these points, you will get the mark. Right, an inequality for the total time each day in minutes that machine A is used is 5x plus 2y is greater than or equal to 180. Find, in terms of x and y, an inequality for the total time each day in minutes that machine B is used. So what you should do, if we can work out how this inequality was arrived at for machine A, we can probably quite simply just apply it to the next one, I would imagine, but we need to make sense of this before we start trying to do the second bit. So how would this inequality for total time each day for machine A end up being 5x plus 2y is greater than or equal to 180? So can we find anything to do with total time? We have the time taken for each pair could be quite useful numbers, so you know that each pair in style X takes 5 minutes on machine A. Each pair in style Y takes 2 minutes, so that can be the 5 and the 2. What about the 180? We need to keep looking. And if you look further up, you can see two machines are used to make each pair of shoes. Machine A is used for at least 3 hours each day. So at least 3 hours means greater than or equal to 3 hours. And this inequality says the total time each day in minutes. So 3 hours in minutes, well, there's 60 minutes in 1 hour. 3 times 60 is 180. So that is where this 180 came from. And the greater than or equal to, as I said, I think I already said it, but I'll say it again, is because machine A is used for at least 3 hours each day. So at least means either that or more. So greater than or equal to 3. So that's where this came from. This is the total time, which it takes 5 minutes for every pair in style X, and there's X pairs, so 5X. Takes 2 minutes for every pair in style Y, and there's Y pairs, so 2Y. The total time must be the time for the X's plus the time for the Y's, and we know it's at least 3 hours. So if we do the same for machine B, well, that says it needs to be used for at least 4 hours each day, or 4 hours in minutes. If 3 hours is 180, 4 must be 60 more, so it's going to be 240 minutes. And then you need to just follow the same pattern. So this was 5x plus 2y because it was 5 minutes and 2 minutes. This is 4 minutes and 5 minutes. So each pair for style X takes 4 minutes on machine B, so it's going to be 4x. Each pair in style Y takes 5 minutes on machine B, so that's 5y. And for the total, we add them. There we go. So equivalent inequality for machine B. The company sells all the pairs of shoes it makes each day. Find an expression in terms of X and Y for the total profit made each day. If you look in this table, you cannot see anything that says profit, but what we can see, if you look at the last 2 rows, you can see one is cost and one is selling price. So hopefully you know that the profit is selling price minus cost price. So prof equals selling price minus cost price. It, as I say, is really tight for space, which is a bit unfair, but I really can't do anything about that, unfortunately. Profit is selling price minus cost price. So we need the total profit. So that's going to be the profit for X plus the profit for Y, and total means we're going to add them. So for X, style X, well, that is going to be the number of X's we make times the profit for each one. So the profit for each one, well, the sale price is 100 and the cost is 20. So that's going to make $80 profit for each pair sold. So that's going to be 80X because that was 100 minus 20. For style Y, selling price is 70. cost price is 15, 70 minus 15, and we take away 10, then take away the 5. That leaves us with 55. By the way, this exam, it is a calculator exam. At any point, if you need a calculator for these, use it if you're not sure. I'm not using it for that just because I don't feel I need it, but by all means, if you're likely to make a mistake, just use the calculator instead. So each pair of style Y makes a profit of $55, and we make we make Y of those. So the total profit, and this word expression means it shouldn't have an equals sign, so don't be tempted to sort of bring some letter in like P equals or something for profit. An expression is usually a combination of letters and numbers and maybe some addition and subtraction and it's got no equals sign. So the total profit is going to be 80x plus 55y. Three lines, x equals 80, y equals 100, 5x plus y equals 180 have been drawn on the grid. Draw two more lines to find the region defined by the 5 inequalities from question 5a. Shade the unwanted region. So what you will find a lot of the time in these investigation and modelling papers, you have to flick back a page or so, or possibly even 2 or 3 pages, to use old results to get to the next bit. So we need to think about all the inequalities that we had. So if you think back to what we were doing before, we had these x pairs of shoes, and we knew that the maximum number of style x was 80. So this x equals 80 corresponds to the inequality x is less than or equal to 80. It was greater than or equal to 0, but if you just look at the way the graph's drawn, it's got kind of an axis here and here. There's nothing outside of the first quadrant, basically. Everything's positive, so we could potentially draw an x equals 0, but it's not going to really help or make any difference. I think I'm just going to leave it. So we want x is less than or equal to 80, so we would end up shading the unwanted region, which I'll do in a bit. Style Y, remember we had a maximum of 100 pairs of style Y that we could make, so this corresponds to Y is less than or equal to 100. 5x plus 2y equals 180. If you remember, if I can just put this over here, that was from here. It was the one that was given to us at the start of 5a part 3 for the total time each day that machine A is used. Remember, it had to be at least 3 hours for machine A. So we know that this corresponds to 5x plus 2y is greater than or equal to 180. So this one here is 5x plus 2y is greater than or equal to 180. It's very important that we know what the inequality is because we need to do the shading right. So we have been asked to draw 2 more lines and find the region. So we're going to need the 2 inequalities that we found and draw the corresponding lines. So if we just go back, the 2 inequalities are, it's the one for total number of shoes, which was x plus y is less than or equal to 150. So we need to draw x plus y less than or equal to 150. So we're going to draw x plus y equals 150, and then we're going to shade the unwanted region. And we also have the one for the total time on machine B that, remember, had to be at least 4 hours. So that was here, 4x plus 5y greater than or equal to 240. 4x plus 5y is greater than or equal to 240. So we're going to have to draw these two lines here. So x plus y equals 150. Well, if you think about that, if you ever draw in a line like this, just think, well, if x was 0, what would y be? If y was 0, what would x be? So for x plus y equals 150, you know that if x was 0, y would be 150, so that's a point. If y was 0, x must be 150. So all I'm going to do is plot those 2 points. So 0, 150 is up here, right at the top. 150 is here, and it's actually all of these inequalities are greater than or equal to, less than or equal to. They're all solid lines, which makes it a bit easier. So for that's x plus y equals 150. Should label it. You get communication marks in these. I will do the shading now as well, I think. So the bit we want is below the line. So what we're going to do is shade the bit we don't want, which is above the line. So just shade the unwanted region like that. Okay. Right. The next line we need to draw is 4x plus 5y equals 240. So if 4x plus 5y equal 240, well, if x was 0, 0 plus 5y equals 240. So that would mean 5y equals 240. So if you're not sure about how to, I mean, you should just be dividing by 10, 24 and doubling 48. But otherwise, just check 240 over 5 is still 48. Otherwise, you could even go to a solver, but you shouldn't really have to do that. But anyway, if x is 0, y is 48. So this must pass through 0, 48. If y was 0, so that would be 4x plus 5 times 0 plus 0 equals 240. 4x equals 240, x is 240 over 4. 240 over 4, which is 60. So that means x is 60 when y is 0. So we need 0, 48 and 60, 0. So 60, 0 is here. 0, 48, well, this is going up to 50. So 1, 2, 3, 4, 5 squares. So there must be 2 each, because it needs to do 10 in 5. So 42, 44, 46, 48 is there. So where's the ruler? Get it drawn, and then we want to shade the unwanted region. So the wanted bit is above, so we're going to shade below, just like that. And then as soon as I've done this, we will shade out the unwanted regions for the rest. So this line here, x equals 80 is that line there. And we want x is less than 80, as that's not equal to, so that's that side. So we're going to shade the bit we don't want, the other side. So I'm just going to shade that out. I'm not too bothered about stuff that's already been shaded for another inequality, but I'm interested in this bit that hadn't. Right, y equals 100 is this line. We want y is less than or equal to 100 underneath the line. So we're going to shade the unwanted part, and I'm just really going to shade this bit that hasn't been shaded. I do a little bit extra, but we're just interested in leaving a nice blank region. One more line is the one that was drawn for us. 5x plus 2y equals 180. It must be the one line that we haven't dealt with, so it must be this one. 5x plus 2, I won't label it, I haven't got room. But we're interested in what bit we want is greater than or equal to 180. That's above the line or to the right. So this bit we want. The bit we don't want is to this side of the line, underneath or to the left. So we shade it out. And just shade the bit that's not been shaded elsewhere. It doesn't matter if you go over, but it's just more for time saving really. So we are now left with a feasible region R. So this now is our region. Once all the constraints have been taken into account, this is kind of gives all the possible values of x and y, and then we're looking now to maximize. Show that the greatest profit is $10,250. So what we need to do is find the maximum value in this region. In here we're only interested on the extremities of the region, so you're looking for the maximum bits, and really if you're looking to minimize something, you kind of want to be on the bottom of a region, but we're looking to maximize, so we're interested probably in this point. Could be quite a good one to check, and that one maybe, and this one, but I think it's going to be one of these. So we're looking to find the sets of x and y that make this true. And if you're just thinking, well, how do I find the profit, because there is a lot going on, if you remember in part 5b, we had an expression for profit which is 80x plus 55y. So if we write that down, 80x plus 55y, so we just need to find the x and the y that make this right. So here on this point here, it looks like x is 80 and y is 70. So what is 80 times 80 plus 55 times 70? So we go to our calculator, 80 times 80 plus 55 times 70 gives us our answer of 10250. And that is enough for the show that we've drawn the region, we've got the point, we know that maximums and minimums are found on the edge of this feasible region. We hopefully remember that from the class work we did. And we've looked for this point, it's probably going to be a maximum. I would have checked that one if this one didn't work. So this maximum profit occurs when x is 80 and y is 70, 80, 70. So that means if we make 80 pairs of style X, 70 pairs of style Y, assuming that we sell them all, this is the best way for this factory to conduct its business in terms of the machines, the times, the styles, everything, the timings. This is the best way for them to do this most efficiently. Question 7 is kind of the last bit of this mini part, and then the modelling thing does branch out a little bit, changes a little bit. The table shows the amount of material for each style. So now we've got a new consideration coming in. Is it how much material is it you actually need to make a pair of shoes? So for style X, you need 0.5 meters squared of material. For style Y, you need 0.4 meters squared. And we have another constraint. There is a shortage of material and 50 meters squared is used each day to make all the shoes. So we've got a maximum amount of material we have available. Draw a line in the grid on question 6 to show this information. Then we need to work out the decrease in the greatest profit. So firstly, what line do we need to draw? So the new constraint is that we have a maximum of 50 meters squared of material. So something is going to be less than or equal to 50. And that is, remember, the total amount of material. So every pair of style X uses 0.5 meters squared, and we make little x numbers of each. So it's going to be 0.5x. That's the total amount of material used to make all the style X's that we make in a day. For style Y is 0.4y. So for the total, we must add them. So this is the new line we need to draw. And I would still be drawing this in the same way. I'd be looking to draw 0.5x plus 0.4y equals 50. And I'd be looking, well, axis intercepts. If x is 0, so if 0.5 times 0 is 0, 0 plus 0.4y equals 50. What does that make y? So that's just making x 0. Remember, this line, the equation will be true all the way along this line. So you can make x and y whatever you want, or you can make one of them whatever you want and then work out the other. But 0 is really, really handy. So that would mean y would be 50 over 0.4, which I'm not going to work out in my head. I'm going to do 50 over 0.4. It's going to be 125. So that means when x is 0, y is 125. For y being 0, that would mean 0.5x plus 0 equals 50. So 0.5x equals 50. That's saying a half of x equals 50. Again, yes, you should be able to do this without, but I would rather you didn't get it wrong. The answer is going to be 100, but if you're not sure, just do 50 divided by 0.5. And we're dividing by a half, timesing by 2, same thing, x equals 100. So that means 100, 0 is a point. So we need to plot 0, 1, 2, 5, and 100, 0. And then we need to draw the line. And remember, it's less than or equal to 50, so we need to shade the other side. So let us get the graph back. Okay, 0, 1, 2, 5 is up here. 120, you've got 5 squares, 1, 2, 3, 4, 5, so we need 2.5. 2.5 squares up, it's going to be there. And then the other one should be easy. 100, 0 is here. Draw a nice line, and this is definitely going to affect our profits. Just like that. And remember, it was 0.5x plus 0.4y is less than or equal to 50. We need to shade the other side. So we are going to shade this side of the line. Right. So now we've drawn the line. This here, this point, which is quite hard to tell exactly where it is, that is now going to be our value with the additional constraint that maximizes the profit. And it's not going to be as good as it was, as the question indicates. So we need to decide where this point is. Well, x is definitely 80. Looking at this, it goes up in 2, so 2, 4. I'm going to call that 25, but I'm not sure at all. There's 80, 25. Hopefully you get a little bit of leeway with this, but it really does depend on the mark scheme. And if it's all about getting your ruler or using a nice sharp pencil, being able to really zoom in, get really close to it and have a good look. But I'm going to go with 80, 25. So I reckon the maximum happens when x equals 80, when y equals 25. So we need to find the decrease in the greatest profit. So we're going to need to find the new profit. So if you remember, as I was saying, you do need to flick around the pages quite a lot here. You just need to practice and get used to it. The equation for profit, the expression for profit was 80x plus 55y. So our new profit equals 80x, so 80 times 80 plus 55y, 55 times 25. Go to our calculator. 80 times 80 plus 55 times 25. So that gives us 7,775 of the new profit. So the decrease in profit must be the old profit minus the new profit, or the new profit minus the old profit, and get a negative. So remember, our old profit was this 10250. So the decrease is going to be 10250 minus 7775, which gives us 10250 minus 7775. So that gives us a loss of 2475. Quite a significant dent in profits with this material shortage.